You know, there's this piece of tech that's absolutely everywhere, making our modern world tick, but I bet you've probably never even thought about it. It's called an inverter, and trust me, it's a true unsung hero of our electrical world. So let's dig in and find out why this thing is so critical.
Okay, so to really get why this little box is such a big deal, let's think about this for a second. Ever been on a plane, maybe 30,000 feet in the air, and wondered, how does this thing power everything? I'm not just talking about your in-flight movie or the coffee maker. I mean the really important stuff, the flight controls, keeping you safe. Well, the answer to all of it, it comes down to our hero, the inverter.
All right, let's jump right in. We're going to start by looking at a modern aircraft because, honestly, it's the perfect example. Think about it. It's basically a self-contained flying power grid.
And this really puts the scale of the challenge into perspective, right? A modern jet, it isn't just a vehicle. It's a city in the sky, a flying power grid. The electrical demands are just huge. You've got your critical flight systems, you've got support systems like air conditioning, and then you have all the stuff in the cabin that keeps passengers happy.
And here's the thing. So many of these crucial parts, we're talking motors and the flight controls, the instruments in the cockpit, all of it, they all need a very specific kind of electrical power. And that little detail, well, that creates a really interesting problem.
And that right there brings us to the heart of our story today. It's a fundamental electrical problem, the DC to AC challenge.
So, to get this, we got to do a super quick review of the two types of electricity. First, you've got direct current, or DC. Just think of it like a one-way street. Power flows steadily, always in one direction. That's the kind of juice you get from a battery. Then, you've got alternating current, or AC. This is more like a crazy two-way highway where the power is constantly and rapidly reversing direction, back and forth, back and forth. That's the power coming out of the outlets in your house.
So here's the problem in a nutshell. The plane's generators, they make nice, stable DC power. But, like we just saw, a ton of its most critical systems, they need AC power to run. And you can't just, plug an AC device into a DC source. It just doesn't work.
And this is exactly where our hero, the inverter, steps onto the stage. Its whole job is to be an electrical translator. It takes that steady DC power as an input, and voila, it spits out AC power on the other side at the exact voltage and frequency needed. So, the big question is, how does this magic box actually do that? How does it make electricity go backwards and forwards? Well, the principle behind it is actually surprisingly simple and honestly pretty cool.
Okay, let's try an analogy. Picture DC power as a river, just flowing along in one direction. Now, inside the inverter, you have these ridiculously fast electronic switches. Think of them as a switchman on a railway track who's had way too much coffee. Their only job is to flip the direction of the current, back and forth, hundreds of times a second. And that rapid, perfectly controlled reversal, that's what creates alternating current out of a DC source. Simple as that.
And that timing has to be perfect. On a plane, those switches are flipping 400 times every single second. That creates what's called a 400 Hz frequency. Now, for perspective, the power in your house is only 50 or 60 Hz, so why so high on a plane? Well, it's brilliant, really. Higher frequencies mean you can use smaller, lighter electrical parts, and on an airplane where every single ounce counts, that is a massive deal. So it's not just about making AC power, it's about making the right AC power for the job.
Now, of course, like any tool in a toolbox, not all inverters are the same. They come in different flavors for different jobs. So let's take a quick look.
So, the two main types you'll hear about are single-phase and three-phase. Single-phase, that's for your lower power stuff, maybe converting battery power to run a small appliance. But for the heavy-duty jobs, like giant industrial motors, or, you guessed it, the systems on an airplane, you need the big guns, a three-phase inverter. It can handle way more power and delivers it much more smoothly, which is, exactly what you want when you're flying at 30,000 feet.
Okay, but just creating AC power, that's only half the story. See, for the super sensitive electronics in a cockpit, that power has to be absolutely perfect, totally clean. And that brings us to the next big challenge, controlling the electrical flow.
Here's the issue. The raw AC power you get from just flipping a switch on and off isn't a nice, smooth wave. It's more of a clunky, jagged square wave. It's full of what engineers call noise and distortion. And this dirty power, it can actually fry sensitive electronics.
And believe it or not, there's actually a way to measure how dirty the power is. It's called total harmonic distortion, or THD. The best way to think about it is like a quality score for your electricity. The lower the THD number, the cleaner the power. The goal is always to get that number as close to zero as possible.
So that leads to the next big question, right? How do you take that rough, blocky, dirty power from the switches and turn it into a perfectly clean, smooth signal that's safe for a plane's flight computers?
The solution is a truly genius technique called pulse width modulation. You'll see it called PWM. And honestly, this is the secret sauce that makes all modern, high-quality inverters work.
So instead of just one big on and off switch making that chunky square wave, PWM is much smarter. It uses thousands of tiny, super fast pulses every single second. And by carefully controlling the width of each one of those little pulses, making some a bit longer, some a bit shorter, the inverter can perfectly sculpt the final output into a beautiful, smooth sine wave. It's kind of like building a high-res photo out of millions of tiny pixels instead of just a few big blocks.
And look, understanding this stuff isn't just about how planes work today. It's really a peek into the future of all kinds of technology, a future that's being called power by wire.
Yeah, this quote really hits the nail on the head. The whole trend, not just in aviation but everywhere, is power by wire. That means we're replacing old, heavy, clunky mechanical systems with lighter, smarter, more efficient electrical ones. And every single one of those new systems needs a high-quality inverter to work. So their job is only going to become more and more important.
At the end of the day, the inverter is one of the key pieces of tech enabling our entire electric future, from the planes in the sky to the cars on the road and the solar panels on our roofs. And that kind of leaves us with a final thought to chew on. As our world goes more and more electric, what other hidden, unsung heroes like the inverter are out there, quietly making it all happen? Thanks for tuning in.